Okay, we're going to try another integral. This is going to be an integration by parts example. This is our new technique, and this is probably one of the most useful techniques for integrating. So let's take a look at the antiderivative, the indefinite integral of x squared times the natural log of x dx. Okay. So let me write down our formula for integration by parts. We have u dv times u equals u times v minus v du, right? So what we're looking for is we want to split this up here somehow as a u and a dv. In other words, a function and a derivative of another function. When we choose, right, so what I'm going to choose is something over here to be u and something over here to be dv. Whatever we choose as dv, we're going to be taking an antiderivative of that. So in this case, for instance, I'm really left without many options. I don't know an antiderivative for natural log of x. We'll actually do that one shortly, but at this point we haven't done that. So if I choose dv to be the natural log of x dx, I'm going to have to take an antiderivative to find v, and I won't know it. So let's see what happens if we take natural log of x as our u. We know that du then is going to be 1 over x dx, which leaves dv to be x squared, which makes v x squared dx, which makes v 1/3 x cubed. Okay. Right. So in doing these in general, it's not always clear what the right choices are. In this case, I think we didn't really have much of a choice with natural log, but it's always worth it to try something and see what happens. So once we've chosen our u and our dv, right? So we just want to check our map. This is our formula or our map, right? So if I look, I've got u. I want u times dv to be what's here. And so u is natural log of x. X squared dx is the other part, right? The ordering doesn't matter too much in multiplication. So this is exactly u dv. So now I'm just going to follow the map. U times v, so I've got a u and a v. I'll write it as 1/3 x cubed natural log of x minus the integral of v times du. So v is still 1/3 x cubed. Our du is 1 over x. So we'll end up with a 1/3 x cubed times 1 over x dx. This is going to give me 1/3 x cubed natural log of x. Let's simplify this a little bit. I'll pull the constant out front. X cubed times 1 over x leaves me with an x squared dx. And now this is a fairly simple antiderivative to take. It's the same one we just took up there. So we'll get another factor of 1/3 x cubed. I'll throw in that constant of integration, and we end up with 1/3 x cubed natural log of x minus 1/9 x cubed plus c. Okay, and I'll leave it to you guys. Take the derivative of the right-hand side, and you should get x squared natural log of x, right? There'll be a little bit of algebra to work out, but it should work out to be the same thing.